Hello everyone, welcome to lecture 5. In this lecture we're going to talk about section 2.4, which is displaying bivariate numerical data, scatter plots and time series plots. So from the definition last time that we've seen last time, bivariate dataset is a dataset that contains two variables. Usually we use the letters or the alphabets X and Y to represent those variables. So if a dataset contains two columns or two groups or two variables, X and Y, we call it bivariate. And usually, in order to look at the relationship between the two variables, or if we have bivariate, in order to see the relationship between the X and Y, the basic and most useful, or the starting point or starting graph that we use is the scatter plot. So the scatter plot shows you a general idea of the relationship between X and Y. So when do we use a scatter plot? If we have two variables, X and Y, and both of them, they have to be numerical. And the purpose is to look at or to investigate the relationship between X and Y. So if we have this, or if these are the criteria, then we use the scatter plot. And to construct, well, just like any other or most other graphs, we draw a horizontal line, which we call the x-axis, and we label this one based on the data values. And usually, as I mentioned up here, we call them x and y. So always we put the x variable on the x-axis or on the horizontal line. So you label based on the values of, or the range of the values of x, you label this line. Let's say if the values of x goes from 10 to 50, then it's up to you. You may start from 0, or you may just want to kind of shrink it just to include the values of x. So you may start, let's say, from 10. You can go on the interval of 5 maybe, or just you list all of them depending on how much space you have. 25 and so on and so forth. So you label this value, and then you draw the vertical line, and again here we have the y variable, and again, of course, depending on the values of y, you label this value, this line. And then for each pair, let's consider a simple example, age and or let's consider height. This makes more sense. And weight. So for the first student in the class, the height is, let me use in centimeters, is 180, and the weight in kilograms is, let's say, 7 or maybe 8. Okay, 80 kg and 180 centimeters. So if I take this to be x and this to be y, then I have to label this accordingly based on the values of height. Let's say if 180 is somewhere in here and 80 on the y-axis is somewhere in here, then you find the intersection point of these two, let's say somewhere in here, and we just put a period, a dot at that point. And if you do for all the students in your data set, let's say if you have 10 of them, so for each pair, put a dot at each intersection, and then you will have some graph that looks like this one. So for example, we have here we have data, and this data is basically about 29 fitness trackers, about their price, and overall score. And the score is based on some kind of factors, ease of use and accuracy of steps and so on. So one is to consider the price of the tracker, and the other is how good is it. Okay, so they give them some score. Now the question is, do we expect or is there any relationship between these two variables? Now take price to be X and the overall to be Y. This is continuation of this one. This part is continuation here. And again, this one is down here. So it's basically we have only 2 columns, not like 6 columns. So is there a relationship between X and Y, price and overall score? So the finished scatter plot looks like this one, and I'm going to show you how to do this one in Excel. So I have the data in Excel already. Okay. All right, so here we have the data, and I'm gonna select all this data. Okay, oops. Okay, we select all the data, both X and Y. I put Y in one column and X in one column, and then I go to insert. And when you come somewhere in here, you have the graphs, the different types of graphs, and this is the scatter plot. Insert scatter plot between X and Y. So if you click down here, you will see different types. The one that I want is just the dots. I don't need the lines, so I will select this one, and here I have the scatter plot. And here, sometimes you may not get the exact type of graph that you want, or you may want to add some other properties of the graph. Let's say you wanted to change title, or you wanted to add X title, Y title, and so on. So you can go here, add chart elements, and you can add the axis elements titles for the horizontal. What do you want to call it? You write it here. So in our case, it's price. And so let me put this one, and vertical, and this one is score. So there's no need to repeat this one, I guess. You can put some other something else here, just a more descriptive title. So yeah, this is how you can construct a scatter plot in Excel. If you, these are the grids, so if you want, you can just leave them. If not, you can delete them. You can avoid both the horizontal and vertical ones, so that you can have just something like this. It's up to you. Now, if we go back to our notes, this is the same scatter plot. Now let's look at this one, because the question was, do they have relationship? So that's what we are trying to answer here. And in general, as we go from left to right, as the price increases, the overall value is kind of increasing. So in general, for those who which are with high price, the score is kind of high. But that's not the only thing that we see here, because we have some trackers which with high price. Let's say, for example, this one. This one, the price is somewhere around 200, but the overall score is around 65. And if you consider this one, those two, the price is 150, which is less than this one. The price of this one is less than the price of this one. But the overall score is much more higher than the score of this one. So still, it's just a general description because they don't fit in one line. So some of them, they kind of are exceptional. Well, not exceptional, but we expect some variability. But overall, we see like an increasing trend. As the price increases, the overall score increases. All right. And the next one is the time series plots. And time series plot is just bivariate data, but in this case, the x variable is measured in time. And instead of, for example, instead of having price or instead of having weight or height as x variable, our x variable here is time. The time could be in days, it could be in weeks, it could be in years, it doesn't matter. But we are measuring some value against time. Okay, so what was um, what was your income in before 2 years? How about last year? How about this year? How about next year? And so on. So you record the data for 10 years, and then you can plot a time series plot. Or days. What was the temperature yesterday, today, tomorrow, and so on. You record the values, and then you plot a line or a graph against time. So this is what we call the time series plots. What happens to the variable as we go with time. Again, if we look at this data, Gallup conducts frequent polls in which large sums of adult Americans are asked how often they exercise. The article used information from this polls to estimate that during the first half of 2015, on average, 52.5% of Americans exercised for 30 minutes or more at least 3 days a week. Now, here we have the data, and we want to see if the number of times a person exercises increases or decreases with time, starting from 2018 to 2015. So looking at this table, well, you can say something, but it's not as easy as it seems to see the trend. But when you put this one into graph, then it would be more easier to see the trend or what's going on or which direction it's going. So the overall line looks like this one. And again, I will take you to Excel. I will show you how to create this graph using Excel. Now, if we go back to this one, I put the data on the next tab, the next sheet. And here we have the data. So for this one, it's the same, but again, I will show you more, like a little bit more steps, because we don't get the exact graph that we want straightforward. It's not like the scatter plot. So first, let's select this one, and we'll see what happens when we follow the same steps. Go to insert. Now, instead of scatter plot, we go to line here. Insert a line or area chart. So we want a line chart here. Okay. So I will click here, and I will choose the first one. Now, as you can see here, it gave us two lines, and those two lines represent those two variables. The first one is for year, and the second one is the lower one is for percentage. But that's what I want. That's not what we want. This is totally different. So what I do is here we have select data. I will again select it because the way it's interpreting is not the same. So I will remove this year from here. Okay, select this one and remove it, because as you can see, the graph for year is not there now. because we don't want the graph for years to be here. Years should be on the x-axis. That's it. We don't want it up here. All right, and then on the x-axis, this is the horizontal category axis. And instead of counting as 1, 2, 3, 4, or labeling it as 1, 2, 3, 4, we want on the x-axis this year, 2008, 2009, and so on. So I will edit this one, and axis label range. I will select now the range. Okay. All of them. Oops. No, didn't select. Yeah. So I selected all of them. So that's what we want. And as you can see this one. The years now become on the x-axis. I will press OK. And again, OK. And that's the line. And then here you can choose. You have different types up here. And you can pick the one you want. For example, if you click on this one, you see like this one. And for example, if you go here, there are different ones, and this is somehow looks like the one that we have on our notes. But anyway, this is how you construct a scatter plot, and this is another way. As you can see, you can put the values, the exact value of that point on the graph. You can include it if you want. Okay. Going back to the notes. Now, after constructing your graph, the next is how do you interpret it? So there, as you can see, there are ups and downs. You don't expect, I mean, it's not a straight line. We start with 2008, it was up here 52, and then in 2009 it goes to somewhere 49 point something. 2010 increased, then 2011 decreased, and 2012 increased, decreased, again decreased, and increased, and so on and so forth. So there is somehow a general trend as you go from here. Overall, it's kind of increasing, but when I say increasing, it doesn't mean it's going straight up. Even though it's kind of zigzag, but the zigzag is kind of increasing. When we construct graphical displays, there are some common mistakes that we need to avoid. Some of these are always the area of the graph or the bar, whatever, what type of graph, depending on what type of graph you're drawing, should be proportional to the frequency, to the relative frequency, or magnitude of the number being represented. So otherwise, let's say if you are constructing a bar graph, when you create a bar, like different bars, different lengths, so this area, they have to be proportional to the frequency of that category, okay, whatever this category is. And again, this area has to be proportional to the frequency or relative frequency of this category. Sometimes, like in newspaper or in some magazines or other reports, you may find something which with this kind of mistake. So let's consider this example. This is very similar to the one that appears in USA Today, and in this graph, as you can see, they replace the bar graphs. Instead of having bar graphs like rectangles, they use this they use this to represent the bars. So the first one, if you consider the first one, this one represents 19 cows. And in the second, in 1980, if you look at the graph, these two buckets, they represent 32 cows. So if one is for 19 cows, how come 2 buckets represent 32 cows? Okay, so that's not proportional. If, for example, this was like 16, then this is 16, this is double 32, and so on and so forth. In that way, it will make sense. But here, it doesn't make sense, or this is a mistake that we need to avoid. This is what we were talking about. This one bucket is not proportional to the 19, or the 32 are not proportional to the 2. Okay. And another thing that we need to be careful or cautious is graphs with broken axes, or axes that don't start at 0. So usually we start, when you draw a graph, we start at the origin. This is what we call the origin. But sometimes if your values start, let's say, from 10, you may want this one to be 10 instead of 0, because there is no need to include, you may think there is no need to include 10, and then you can go till the end of, or the maximum value of your data variable. But sometimes this may cause, or this may end up with misinterpretation. So we have to be cautious on interpreting such kind of graphs. Watch out for unequal time spacing in time series plots. So in our earlier example about the time series plot, it starts in 2008, 2009, and so on and so forth. So what would we do if we didn't have the data for 2009, let's say? So from 2008, we jump to 2010, to 2012, and then after 12, then maybe it's 2013, 2014. So here we started by, like, we record data for every 2 years, but then here it's consecutive for every year. Therefore, in this kind of things, or in this case, it will not be as easy as we think constructing this time series plot. Okay, so we have to be careful, and we have to look for alternatives instead of just following the steps that we learned here. And then be careful how you interpret your patterns in scatter plots. So when you have scatter plot, we should be very careful in interpreting the plot. A strong pattern in scatter plot means that the two variables tend to vary together in predictable way, but it does not mean that there is a cause and effect. This is very important thing in looking, or in statistics. When we talk about relationship, we cannot conclude with cause and effect, okay? Because it's kind of observational data, or observational study. You remember, if it is experimental, yes, we can talk about cause and effect. But if it is observational, there is little that we can talk about cause and effect, because we don't know what caused that thing. But from the graph, if I have scatter plot, something like this, then I can say there is an increase. There is an increase of the two variables. As one increases, the other is increasing as well. Okay, so we can see some relationship between the two variables. They are going up together. But does it mean the reason why the y variable is increasing is just because x is increasing? Well, we don't know. Maybe this could be the cause, or it might not. Okay, so we shouldn't do this conclusion. We should be very careful. Sometimes it could be, sometimes it might not. Okay.